In this video, we're going to talk about how do you prove that two sets A and B are equal. So let's start off reminding ourselves of what's it mean for two sets to be equal. So here's the definition. So let's let A and B both be sets. We'll say that A equals B when both 1, A is a subset of B, and 2, B is a subset of A, are true. So when both of these containment statements, 1 and 2, are true, then that's when A is equal to B. So here's the example that we're going to do to demonstrate how you might go about trying to prove the two sets are equal. And the example that I have here is to try to prove that the complement of A union B, that's what the exponent C means, it means complement of the set. So remember, that's everything that's not within the set. So that's not within the parentheses there. So I want to show that the complement of A union B is the same thing as the complement of A intersected with the complement of B. And you might recognize this if you've seen some of this stuff before and just are watching as a refresher. This is one of De Morgan's laws. And it kind of tells you a way that the complement sort of can distribute over unions and intersections. You just have to be careful because you notice that the union on the left changes to an intersection on the right if you think about distributing that complement through in like an algebraic kind of way. Okie dokie. So before we actually formally prove how to do this, let's just draw some little pictures with some Venn diagrams to make sure that this makes sense. So what's the intuition for why these two sets should be the same? And then we'll look at the more formal argument for how to do it. All right, so on the left, I've colored the union of A and B in yellow. So there's A or B colored together, or A union B. But now what I'm going to do is I'm going to take the complement of that. And when you take the complement of that, remember that's just everything outside of the union. So I've shaded that kind of whitish color. And let me zoom in a little bit too so we can see a little bit better. So the left side is that shaded region that's just outside of the two circles A and B. Now what I'm going to do is look at the right-hand side. So let's think about A complement intersect B complement. Well, I've got A complement up there on the right, and it's in blue. So remember, that's just everything that's not in A. And then next to it, I'm going to draw another picture that's B complement. So that's everything that's not in B. And now what I want you to imagine is what if I lay these two pictures over each other? So like laying them over each other, I'm essentially getting ready to take the intersection. And so what's that look like here? And you notice that like there's still some color left inside of the A circle, and there's still some color left inside of the B circle. But what I want you to focus on is where did the two colors mix at? And where did the two colors mix? Well, that's outside of both the circles. And so if I clean this up a little bit and just put down where the two colors mix, again, we arrive at the same region that is just outside the two circles. So that's kind of like an intuitive kind of way to convince ourselves that this statement should be true. But of course, you can't do a proof by picture. I don't think your professor would like that very much. So we should practice how do we go about showing these two sets are equal more formally. So here's the proof. And what we're going to do is we're just going to try to use the definition above. Again, what does it mean for two sets to be equal? I just have these two subset arguments to run through. So the first thing we'll do is I'll start on the left side. We'll try to show that the complement of A union B is a subset of A complement intersect B complement. And so I'll try to do that within this space here. Wish me luck. And so first, let X be an element of the complement of A union B. And remember, the goal is to try to wind up and try to show that X is actually an element of A complement intersect B complement. So what we're going to try to do is just think about what does that mean if X is in the complement of this union? Well, that just means that X is not in A union B. Now I want to think A is definitely a subset of A union B. So if X isn't in the whole union, then it's not in any part of the union either. So because X is not in A union B, I know that X cannot be in A. And again, that idea, if X isn't in the whole thing, it can't be in any part of it as well. Now what I'm going to do is I'm going to try to apply that same logic. So maybe before I do that though, just one more thing. Remember, when X is not an element of A, that's the same thing as saying that X is in the complement of A. Now what I want to do is that same logic. I know that B is also a subset of A union B. But I know that X is not in A union B. So if X isn't in the whole union, then it can't be in any part of the union either. So X cannot be in B, and of course we can translate that into X is in the complement of B as well. And so if I look over there to the far right, I've got X is in the complement of A and X is in the complement of B. So of course that means that X is in the intersection of those two complements. And since X was just an arbitrary element of the complement of the union. In other words, it's an arbitrary element of the thing on the left, and we've shown that it has to live on the thing on the right. That's enough for us to say that these are subsets of each other for that direction. Now, so we've essentially just proved like, the orange one up there. We've done that one direction. You can't forget to do the other direction, right? We've not demonstrated these two sets are equal. Now we've got to go the other way. So now we're looking at statement 2. What if I switch these containment relationship around? And so now we want to show that A complement intersect B complement is actually a subset of the complement of the union. And again, I'll try to do that in this little space that I have right here. So let's do it to it. So now let's let Y be an element of A complement intersect B complement. You could have just recycled X over again, as long as you understood that the X that you used right here is not related in any way to the X that you used in the previous argument, but just for presentation purposes, I picked a new letter. So Y is an A complement intersect B complement, So what does that mean? Again, you're just translating like, what is that definition? So that means that Y is not an A and Y is not in B. What we want to think about is, what's another way to say that? What's an equivalent way to say that? Well, an equivalent way to say that would be that Y is in neither A nor B. So Y is in neither A nor is it in B. And that tells me that Y is not an A union B. So in other words, it's not an A or B. So we're just kind of talking through what does that mean and then writing those symbols down that correspond to the correct way to say this. But if Y is not an A union B, another way to say that is that Y is in the complement of of A union B. So that is a typo on my part. That intersection sign should be a union at the very end down there. So pay no attention to it. But I think I fixed it in the next part. So thus, A complement intersect B complement is contained in the complement of the union. And so again, just to continually draw your attention to that so that you don't make the same dumb mistake I did, this should be a union so that it matches this. So my apologies for that as we're going through it. And so what have we done? We have gathered the information that A union B complement is contained in the intersection of the complements, and we have just also convinced ourselves that the intersection of the complements is contained in the complement of the union. Therefore, these two sets must be equal.